Hi, I'm Jordan, and I would like to talk about the iodide clock experiment that was recently scheduled for us to do, and it was a pretty involved experiment. So I'd like to talk about my results and the steps I need to take, as well as the science behind it. First, I'd like to show you the materials that I used, and here's the vitamin C that was used. So I'd have enough iodine. Here's the iodine that I used. And here's this distilled water that I used as well. And now I'd like to show you hydrogen peroxide that I used. Lastly, here's the cornstarch that I used. So regarding picture A, I'd like to talk about how I had a mix of vitamin C as well as colorless I- ions and acidic protons, which formed a colorless iodine solution. And as for the second picture that I had to fill up and use, that had hydrogen peroxide and starch. So that is pretty important to note. When mixed together, two reactions are actually occurring, not just one, and these two reactions compete and push each other back and forth. First, I'd like to talk about the first reaction, which involves the hydrogen peroxide wanting to oxidize the I- back to colored I2, but at the same time, the second reaction that wants to happen is the ascorbic acid wanting to reduce it back from I2 back to I-, and eventually, because of the excess of hydrogen peroxide, the vitamin C is consumed so that the I2 complexes with the I- to form a trioxide complex that complexes with the starch, causing the initially clear mixture, when the mixtures of pictures A and B are mixed, to turn into a dark blue solution. And the change should take about a minute or so, not much sooner or not much later. And I'd like to talk about my first run, because I had to end up doing a second one to get accurate results. I initially used pure vitamin C tablets for adults that were not chewy, and the solution was mixed with distilled water, and ended up being a brown instead of a clear color when filtered out, oddly enough. And I'd like to show you what I used initially. I used these tablets to get the brown solution initially. And here's the solution from the first run, but I didn't end up using it for the second run. And for the second run, it went much better when I ended up using this brand. So that's something to take note of. Going back to the reaction itself, these reactions form two types of iodine, and the two main types are the elemental form of iodine and the iron form iodide. So I would like to note that the iodide ions inside the liquid iodine react with hydrogen peroxide to produce the iodine element, which is blue in the presence of starch, but the vitamin C that I added does not get along well with the iodine element. In fact, they break each other apart. So since the iodine element is being torn apart, the solution initially cannot turn dark blue until all the vitamin C gets used up. Once the solution is mixed together and the vitamin C is all used up, it can break apart all the new iodine element that is being made so the solution turns dark blue/black. And as there are fewer molecules to get in the way of iodide and the hydrogen peroxide reacting to form iodide, then the solution ends up moving much faster and the vitamin C is used up faster as well. And when the vitamin C is gone and used up, then that's when we see the color change. And I'd like to show you my results and the way that the picture turned out. This was initially clear, but now it's a dark blue/black color after pictures A and B were mixed together, which had two different solutions. To make the experiment even more accurate for other people in the future, I think that type of vitamin C that would be specified would make a huge difference, even though it was mentioned that we should not use vitamin C that's chewable or for children. I still think that recommending a specific brand instead would definitely improve the results of the experiment for others. Also mentioning a more specific amount of organic cornstarch to put in, I think would also make a huge difference, because that was not explicitly stated. They said guess and measure, but if we were given a specific amount, that would have made certain aspects of the experiment easier, because it's easy to add too much or too little. That could have a huge impact on the experiment. Of course, I also used distilled water instead of tap water, but maybe there's a specific brand that could be recommended as well, just to make sure that the specific distilled water does not alter the experiment at all. My final comments about the experiment itself is that ultimately when the two solutions that I made are mixed together, the goal is to form a trioxide complex that complexes with the starch. It was actually right the first time, and it's a triiodine complex that complexes with the starch, not trioxide, causing the initially clear compound to turn dark blue. And that's the main goal of the experiment, to form the triiodine complex and to turn the complex that was initially clear into a dark blue solution. Thank you for your time.